Yes, good morning, students. Sorry for the delay. I'm at my college. Because of some network issues, I couldn't connect early. Just a minute. I'll begin another 1 more minute. So coming back to here, yesterday I've already discussed about the different tests to be carried out. Tests on bitumen here mainly. What are the tests on bitumen and also what is bitumen and tar? Brief explanation. So moving back to the next is that is cutback bitumen. See what happens whenever we take any bitumen, we do not directly consider it as a bitumen. We may take it in the form of the cutback bitumen, or we may take in the form of a emulsion bitumen. So cutback, usually what happens, viscosity of a bitumen is reduced by volatile dilutant like anything water or kerosene. Those dilutants are used to make the bitumen into a cutback bitumen. Next, what are the types of cutback is like, there are three types. We said as rapid curing cutback, medium curing cutback and slow curing cutback. So whenever I say these three types, so you can also remember in this way, like RC means rapid, R for rapid, and C means curing or cutback, sorry. C means cutback, like rapid cutback, and later on M means the medium curing cutback, and SC means slow curing cutback. So usually, even the cutbacks will be always given to you by mentioning these type also, like RC1, RC2, RC3, or MC1, MC2, MC3, like in that way, so that we can easily come to know which type of cutback it is. Moving to the next is bitumen emulsion. I'll try to go for a slideshow. Yes. Yeah. So cutback bitumen. I hope I'm clear about the what do you mean by cutback bitumen and how it is been prepared. So it will be similar to the bitumen, but what happens? We will be mixing with some dilutant like water or kerosene. And coming to the bitumen emulsion here, bitumen emulsion is actually the substantial amount of bitumen is suspended in some finely divided condition in an aqueous medium and stabilized by one or more suitable materials. So what happens? Bitumen emulsion, actually we use some emulsifiers. So those emulsifiers are something finely graded and all. What happens? We mix that with the bitumen, and that bitumen, which is a semi-viscous liquid, becomes into an aqueous medium. Aqueous medium is not viscous or not solid in that way. So an emulsion is a two-phase system consisting of two immiscible liquids, the one being dispersed as a fine globules in the other, in that way. So these bitumen emulsions can be used without heating for preparing the mixes. So you can use these bitumen emulsion with the aggregates also. You can use directly the bitumen also, or you can take the cutback bitumen also. So emulsions are useful for mainly the patch repair works and interface treatments. So patch repair works means you could have seen like in some roads because of some potholes coming on, because of the disintegration of the road surface, or because of improper subgrade below that. What happens on a road? You may have seen bigger potholes, right? That potholes we usually say it as a reflection cracks. What happens if the below subgrade somewhere in your pavement structure, if the below subgrade is has been failed there, what happens, that will be reflected on the top surface, and because of that a failure may occur. A crack may occur, that we usually say it as a reflection crack. There are different types of cracks we can come across, like the other I don't know why students are very less now. Okay, I'll try to see just a minute. Meeting info. Yes. Okay. So that's what like usually there is not like a particular pothole. There are different types of cracks. We say like alligator cracks are there. Those all we'll be studying in detail in your some of the electives related to transportation engineering there. So here emulsion mainly any pothole on our roads, that pothole is been patched or that is been repaired by patching with the help of emulsions. So here is just a small image which I got actually, like anoic emulsion and another is cationic emulsion. So for example, this is the bitumen globule and it has been surrounded by the positive or negative ions depending on anoic or cationic. So there are different types of emulsions again. It's the same in the same way like the cutback bitumen, we have the different types of emulsions also. Like you can see here, rapid setting emulsion we say, mainly it is used for surface treatment and also penetration macadam and track coat. Track coat. What happens? Usually what happens whenever I draw the pavement structure, if I take any bituminous layer, what happens? For example, I'll write this as a bituminous layer. I'll write it as BIT, bituminous layer, and below there is a granular layer, granular layer. I'll write it as GSP, granular base course, and above this there will be a base course. What happens? This is completely granular layers, means completely of aggregates. This is completely of aggregates. This consists only of aggregates. I can say aggregates, only aggregates, right? So what happens? This is only of aggregates. Whereas here, the next layer is the mixture of aggregates and bitumen. So what happens? This, whatever this interface is there, this interface, what happens? Just that interface should be first treated or something should be applied. That we say it as tack coat, TC, tack coat. Another is prime coat. These are the two applied. So you can remember in this way, like tack coat would be first, like alphabet first in the word, like tack coat will be the first and prime coat. Usually I will say what they will do. For example, this is the GSP layer, GSP, and below there is somewhere here I will draw better to understand. And this is somewhat like this is the subgrade. This is the subgrade below, and above the subgrade you have put all the aggregates, and you have prepared the GSP layer, that is granular subbase layer. And above this granular subbase layer, you have again laid some aggregates, which we say it as wet mix macadam. Those will be wet because GSP acts like a moisture, that is drainage layer. That's why above that layer we will be providing another layer. We say it as a base course. That material used in that we say it as wet mix macadam. About macadam and macadam roads, everything I have taught you in the unit 1 only. The history of roads I have taught you. Telford, macadam, and all those roads before. That is the past history of the roads. So base course. So beyond this base course, what they will do? They will put a thin layer of, we say it as TC. I'll write shortly. That is tag coat. And beyond, above this tag coat, there will be a prime coat. Sorry, I've written in the reverse way. It is first will be prime coat, and later on will be tag coat. Later on it will be tag coat in that way. So rapid setting is usually used in tag coat, and later on medium setting bitumen emulsion. is used for surface dressing and penetration macadam. Penetration macadam, nothing like that. Whatever the layers, so after this PC prime coat and TC tri coat, we will be providing the bituminous layer. This bituminous layer may consist of any two, like we say it as dense bituminous macadam. See, I'm mentioning the words clearly with the abbreviations is because again you need to remember these layer names during the pavement design, that is in unit 5. So dense bituminous macadam and bituminous concrete. So ఈ రెండు లేయర్ bituminous layer లో ఉంటాయి. సో లేదంటే ఒక్కొక్కసారి ఏం చేస్తారు విలేజ్ రోడ్స్ లో ఈ రెండు లేయర్స్ కాకుండా వాట్ దే విల్ డూ, దే విల్ ప్రొవైడ్ ఓన్లీ వన్ లేయర్ బికాస్ ఆఫ్ very low volumes. In place of these two, dense bituminous macadam and bituminous concrete, they provide only one layer that we say it as SDBC, semi-dense bituminous macadam, SDBC, semi-dense bituminous macadam. So like that, mainly this SDBC, a single layer of bituminous layer is provided, and above this will be providing a surface dressing layer or a wearing course layer, we say. So BC and DBM both are provided mainly on a high volume roads like national highway, state highway, major district roads, other district roads and all. And even for the urban roads, what they will do, they will not they may provide DBM. Even if for expressways, what they will do, they will not provide DBM, they will provide only bituminous macadam. See, whatever I'm talking about, like if I say first I mentioned BM for what, bituminous macadam for expressways, because this will consist of the aggregates of bigger size. That's why it is in top, and later on comes the DBM. If high volumes and mainly for national highway, we will go for DBM. So BM or DBM, any of this may be used. Bituminous concrete will be common for any of this. It will be common. Whereas leaving both this, only one is been provided, that is STBC, mainly for village roads. I hope I'm clear. So moving to the next. So first step is rapid setting bituminous emulsion, second is medium setting bituminous emulsion, and third type is slow setting. Slow setting is used mainly for prime coat, and another is slurry sealing. Slurry sealing means already I have explained you, if you take any cement concrete pavement which will be having slabs, right? So between these slabs, whatever the joints will be there, it may be a transverse joint in transverse direction. So this is transverse joint in transverse direction, and this is longitudinal joint in length direction. So within these joints, some bitumen will be poured. That bitumen emulsion, that is slow setting bitumen emulsion, can be poured in these joints as a slurry seal treatment. So these are the two forms of bitumen, I can say, cutback bitumen, and as there is bitumen emulsion and their types. Right? So coming to the tests on bitumen emulsion again. So these are some of the tests to understand. As an exam point of view, they may not ask. You should know what are different forms of bitumen mainly. So the tests of bitumen are like residue test, stability test is there, water content test is there, viscosity test is there, coagulation at a low temperature, and later on sedimentation, and later on long period storage stability. Next, uses of modified in road construction. So I will now move to the next, that is modified binders. Modified means whatever the bitumen is there, they may not have the proper, I will move to the another slide, just a minute. So whatever the bitumen we talk about, those bitumen may not have a proper strength. So we need to modify them. So even any soil is not having a proper strength, what we will do? We will be changing, right? So in that way, we need to change the properties of the bitumen by adding some material. Those we say it as modified bituminous binder. See, we can say bitumen as a bituminous binder also. Nothing difference in that. I have that is a PDF. I'll be trying to share again. Yes. Here it is. Okay, I hope my screen is visible. So this notes I'll be sharing with you. So this is a very brief notes here. So for better understanding of you. Yes, so here you can see. Yeah. So here you can see like asphalt. So I've written about the asphalt here. Just a minute. Yeah, so asphalt, that is usually asphalt, that is bitumen plus any inert material which is non-reactive material. Asphalt is usually called the bitumen is nothing but asphalt, whereas the United Kingdom or others, they will call it as the asphalt also. So advantages, this I just want to recap all whatever I discussed till now. Advantages in a very high temperature, as I already mentioned you, and is also cheap. Coming to the tar, already I've discussed all this. I'll move to the next. Tar I've discussed. It is not so safer to use the tar. Cutback I've discussed, right? So cutback, that is bitumen plus whatever the plus any diluent. It is higher order. It may be a petrol, kerosene. Sometimes they will use water also. So here, like any petrol, diesel, kerosene, that can be used as a diluent there. So purpose is to reduce the viscosity of the material, mainly bitumen here. And for mainly the cold countries or any colder regions, this is cutback bitumen is used, and mainly for the patch up purpose, we can say. And coming to the emulsion here, emulsion what we do, that is bitumen plus water plus emulsifier. So usually these bitumens are sprayed at a higher speed, and already you have seen depending upon the types of the bituminous emulsion at where they are used, right? Okay, coming to the next is this test on bitumen. Already I've discussed. Penetration test I've discussed, right? So penetration test I've discussed, and after penetration test, so penetration test to determine the whether a given bitumen is soft or not. That one. Right. Move to the next is, actually I want to annote on this. I'm not getting. Sorry, just a minute. Yeah. So I was talking about the tests here. Penetration test to determine whether the given bitumen is soft or hard. It is a lab test. So penetrometer is required. So depth of penetration in 5 seconds is to be noted. So one unit of the depth of penetration is 1/10 of mm or 1/10 of centimeter, right? So bitumen penetration grade of the bitumen is based upon this test. So as 60 by 80 penetration grade commonly used, will be having 6 to 8 centimeter penetration. That's what 6 to 8. 60 by 80. 60 means you can write 1/10 means you'll be getting in mm. So already I've explained you. For example, you'll be getting this type of questions only, or in the competitive exam they may ask this type of questions there itself. So they may ask you in this way, like they may ask you like what is the which is the softer material. Like here I can see if G is equal to like 100 by 120 and G is equal to 60 by 80, right? So which is softer? So which is softer here? Since the penetration is more here, that's why this is the softer. Here the penetration is only 6 to 8 mm. Here it is 10 to 12 centimeter. That's why it is softer that way. So 100 by 200 grade of bitumen is more softer. So in that way we need to explain them. Sorry. Ductility. So coming to the ductility here, ductility mainly we require the whatever the thin wire, duct means thin wire. Ductility testing machine is required, and 27 degrees and standard temperature should be maintained. Briquette mold is being required there, and after briquette mold we require the whatever the elongation taking place will be taken in centimeter at the failure. And desirable I mentioned as 60 centimeter. Here it is 50. Sorry, it's not 50, it's 60 centimeter. Viscosity test. resistance to flow or measure of consistency. One is orifice viscometer, we use it. Another we can use tar viscometer. I explained to you about the tar viscometer. So I'll move to the next, specific gravity. So specific gravity is usually conducted using the density portal there. And coming to the softening, I have discussed a simple experiment where we mainly require the ring and ball apparatus. Here you can see this is the ring and ball apparatus. So this ring and ball apparatus is required, and we need to fill in the rings, we need to fill the bitumen, and we need to place the ball on those rings, and those balls will sink into the bitumen and they will fall and touch this stand, that is base plate of the stand. So temperature at which the bituminous plug touches the lower base of the stand or lower bottom portion of the stand, at that temperature we need to note down, that will be the softening point, right? Moving to the, here it is just to understand for your purpose, to understand clearly all, like viscosity grade. Another, nowadays we are using only viscosity grade, we are not using paving grade, we will be saying viscosity grade, that is VG. Wherever you see VG30, VG60, that is viscosity grade. So whenever I say VG60, nothing but it is having a softening point of 40 degrees centigrade, that you will be determining from softening point test, and penetration grade from the penetration test, and viscosity based upon the viscosity test. So coming to the flash and fire here, flash and fire test for safety measure of the bitumen, as already said, Penske Martin's apparatus will be used. So flashes will be coming depending upon the temperature. So heat the sample above the that is above 100 degrees centigrade, the water gets converted to vapors and heat is transferred to a bitumen, which then starts vaporizing. At this point it gives us a cracking sound, which indicates to stop the test for safety of apparatus. So if you continue, then the bitumen may catch fire. Solubility test, this is required, but as per your syllabus, he has not mentioned everywhere. For bitumen, we will be using benzene to determine the solubility test. For tar, we will be using toluene. Solubility test there. Okay. So moving to the spot test. This I have missed yesterday. I didn't explain. That's why I want to recap all the things, and I want to explain about this spot test here. So spot test is one more experiment which is required. This is somewhat a new experiment. Nowhere in the Google or so, nowhere you will be getting these details because there are different types of, there are different other materials. There also will be conducting spot test. That's why it will be confusing. So listen here carefully. Spot test is mainly to determine the overheating or cracked bitumen. So to determine the bitumen, whatever you have, is it a good bitumen or is it a cracked bitumen or overheated bitumen? So what we need to do, we need to take a filter paper. We need to take a filter paper. Okay. So I written here filter paper that will be easily available in your laboratories, and we need to pour a drop of a bitumen. So we need to pour a drop of a bitumen, not directly bitumen. What we need to do, we need to mix naphtha with that. So you may get a doubt how much bitumen should be taken. So that in that way, you have to take just a 10 ml, only a 10 ml of bitumen, only 10 ml of bitumen. So what we need to do, you need to heat the bitumen to a pouring temperature of 90 degrees centigrade, 75 to 90 degrees centigrade, and we need to mix naphtha with it, naphtha, and that mixture we need to pour like a spot on the filter paper. You can see a spot in this way, drop of a bitumen. How much? Just you need to take small drop of a bitumen there, drop of a bitumen with the help of any pipette. If you have a pipette, you know how to use the pipette. So using that pipette, you can just put a drop of the bitumen on the filter. So what happens? And this spread is uniform. If the spread is uniform, then the bitumen is good. What happens? The circles will start spreading, right? So the whatever you put a spot drop of bitumen, that bitumen may spread and the circles will be formed. If the circles are spread in uniform, then it is good bitumen. If the circles are dark and non-uniform, then what we can say, the bitumen is overheated or cracked, and even spreading for a smaller area is there. then the bitumen is overheated or cracked. So loss on heating to 163 degrees centigrade for 5 hours should not be greater than 1% by weight. This is just a criteria here. Yeah, I'll move to the next here. Just a minute. Yes. Okay. Next, water content not more than 0.2% water content of the bitumen. Because see what happens whenever we say water content, usually one of the enemy to the bitumen is water. That you have to remember. Because whenever the bitumen comes in contact with the water, what happens? The bitumen may lose its whatever the stability or may lose its ductile nature that happens. That's why whenever the water comes on the pavement, the pavement is being provided with some chamber, right? Why? Because whenever the water comes on the pavement, that should be easily drained off to the side drains. No water should be left on the bitumen surface. That should be taken care because the enemy for the bitumen is water itself. Okay, so I'll be moving to the next. That is cutback tests. So cutback already I've discussed the types, right? Rapid curing, medium curing, slow curing. So here you can see how the grades will be there, like RC0, RC1, RC2, RC3 in this way, MC0, MC1, MC1 in this way. And moving to the next, that is, so as the number increases, viscosity increases, the fluidity increases. Like RC0 will be having less viscosity, whereas RC5 will be having more viscosity. Like RC means rapid curing cutback. So RC0, a rapid curing cutback with grade 0, and RC5 means rapid curing cutback with grade 5. So as higher grade means more viscosity, I can say. Okay, coming to the tar is actually not so important. So I will be moving to the next test, that is Marshall stability test. And maybe I'm left with the bituminous binders here, modified bituminous binders. Yes, modified bituminous binders. Application of modified bituminous binders. Because Marshall stability is one of the very major tests, but I see very less number of students have attended, because Marshall stability is very important. Because if you understand Marshall stability very clearly, if you take any major project on transportation engineering, you need to conduct Marshall stability test. Okay, I can't help the other students. I'll try to how much I can cover, I'll cover today, and remaining I'll be covering tomorrow. Maybe hardly I may require another 2 classes, I can say maximum 2 or 1 classes is required. Only Marshall stability test is been left, and another is uses of modifiers in road construction. This is left. Only these are the 2 topics left as per the syllabus is concerned. Yes, I'll be moving to the Marshall stability without not wasting much time, because test on bitumen, in that this is another test. Since I have discussed all the tests, including spot test also, I will be sharing these notes also. If you go through these notes and try to write from these notes, that is more than enough. Yes, moving to the Marshall stability test. So this is recommended by Indian Road Congress only for hot mix process. Even nowadays, what happens, since because this point I have mentioned, because nowadays we are using a cold mix also. Cold mix, we usually say it as warm mix asphalt. Nowadays, that is the trending now. That is warm mix asphalt is the trending, or cold mix asphalt is the trending now. There is more research going on in that, because nowadays what happens, because of more heating of the bitumen, it is polluting the environment, and also more bitumen means we need to do the fractional distillation of whatever the petroleum crude. For that we need petroleum in our country. So that all is there because of the rise in the petrol price and all. What they are doing, they are trying to go with the cold mix. Nowadays, the most research topic in the transportation in terms of material is stabilization one, another is warm mix asphalt, I can say. Yes, moving to the procedure here, you can see ingredients of the bituminous concrete. So bituminous concrete, I hope you have heard that term. That is the top layer in the bituminous layers. So bitumen, that is binder. So what we require, one is bitumen, that which acts like a binder there, whereas in cement concrete, cement will act like a binder, right? So again we require the mineral aggregates, that is coarse aggregates, strength purpose, and fine aggregates, wide filler, and fly ash also has a wide filler. Remember, so whenever in exam, if you ask you to explain a brief procedure of Marshall stability test, then you need to start explaining about first what are the materials used, right? So here PPC, that is Portland Pozzolano cement with the fly ash can also be used there. So coming to the, so coarse aggregate for strength purpose we are using whatever the aggregates you are seen in your laboratory test, in the laboratory classes. Fine aggregate is actually the wide filler. We usually say it as a stone dust. Nowadays we are mainly going for a robo sand or M sand depending upon the availability. Coming to fly ash, that is a wide filler. So this rubber sand can't be used in concrete works as it will not give the better workability. Rubber sand and M sand. Moving to the next. So I've discussed in Marshall stability about the materials required. So I'll be moving to the next is, so how this bituminous mix is prepared in the Marshall stability. So what happens, this aggregates whatever we are taking, bitumen will be there and solids will be there and air will be there. What is this three-phase diagram, right? So whatever you have studied in your GT, geotechnical engineering or soil mechanics, right? So whatever the water in the three-phase diagram will be replaced with the bitumen here, bitumen. Okay, so coming to the sample preparation here, we need 1 bag of coarse aggregates which acts like a strength purpose, and later on 1 bag of fine aggregates here, and later on bitumen is required. So bitumen is taken from the field, right? So aggregates and fine aggregate, coarse aggregate and fine aggregate you can easily get from anywhere if you approach anyone who supplies the aggregates there. But whereas for bitumen you need to approach some road construction work, wherever the road construction work going on, you need to approach them. And moving to the, and tested in the laboratory for quality check. You need to do all the tests related to aggregates first, like all test on aggregates and also all test on bitumen. Clear? And this is the mold size for preparation of the Marshall stability specimen. Marshall mix specimen. I can say that is 10 centimeter dia and 6.3 centimeter height. Even maybe I'm having the PPT. I think. Just a minute. Okay, I'll try to show you the images tomorrow. No need to worry. So I'll move to the next. Yes, coming to the steps involved in testing in the laboratory. So before that, what we need to do, I will try to explain here itself. Whatever I explained here, like the coarse aggregate, fine aggregate, and bitumen, all these three are taken. So what we need to do, we need to take exactly 1200 grams of aggregates. That is coarse aggregate, fine aggregate, and the binder, whatever like fly ash. So sorry, not binder, that is filler, I can say. Just a minute. That is wide filler that you need to be taken, that is fly ash. So coarse aggregate, fine aggregate. So all this together 1200 grams consisting, and 1200 grams for this we will be adding about only 3 or 4%. I'll be trying to show you the another presentation. Just a minute. I have kept everywhere. That's the problem. Yes, I have left with another 5 more minutes. So I'll be preparing about just sample preparation, about testing and all I'll be discussing tomorrow, and what all should be done after the test. Marshall stability is actually a very vast because you will be learning only in this transportation engineering subject also. Already you have completed with the lab, you have not conducted any Marshall stability test. That's why I want to stretch upon this test. That's why I'm struggling this much to explain you. Yes, here you can see all the images here. This is the manual and even you may have this manual, that is highway technology manual with you. You can just go through. This is my transportation engineering manual for 4 years. So already I explained you about the apparatus required, right? So here you can see the procedure here. The procedure is first the selection of the aggregates. I have said you coarse aggregate, fine aggregate, and later on the filler required. So here you can see the grades here, right? So we need to select any one grade here. Like here I can see there is a grading requirement for the aggregates here. For example, the layer thickness is 50 mm, and another layer thickness for grading will be 30 mm or 40 mm. So these are the sieve sizes. First you need to take all these sieve sizes to 26.5, 19, 13.2, 9.5, 4.75, 2.36, 1.18, 600 micron, 300 micron, 150 micron, 75 micron. Okay, and later on we have to keep all these set of sieves one above the other, and you need to pass the aggregates, and you need to see that 100% passing of the aggregate will take place in 26.5, and later on 90 to 100 within this range. The passing in case of 19, similarly in other sieves. So you need to see all the aggregates are passing within this given range. If it is not passing, take other aggregates again. Remove those aggregates, take another other aggregates. So this passing should be there. If this passing is not there, then you need to reject those aggregates. You need to take fresh aggregates. Usually what happens, we will at least be getting nearer. See, ఇప్పుడు ఏంటంటే 1200 grams అనుకోండి, 1200 grams అంటే ఇప్పుడు 100% అంటే మొత్తం 1200 grams మొత్తం పాస్ అవుతుంది ఇక్కడ కింద. తర్వాత 90% పాసింగ్, 90% పాస్ అవుతుంది, అంటే 10% మాత్రమే రిటర్న్ అవుతుంది. 10% అంటే ఏంటి, 120 grams, 120 grams 0 to 120 grams రిటర్న్ అవ్వాలి. ఎక్కడ 19 mm పైన, 19 mm పైన. అలాగా పాసింగ్ అంటే ఏంటి, పాసింగ్ అంటే అంత పాస్ అవ్వాలి, మిగతా 10% రిటైన్ అవ్వాలి. సో 19 mm పైన ఒక 0 to 10% రిటైన్ అవ్వాలి అగ్రిగేట్స్, అంటే 0 to 120 grams రిటైన్ అవ్వాలి. అలాగా మిగతా సీవ్స్ కూడా మీరు చూడాలి ఎంత రిటైన్ అవ్వాలి. ఆ రిటైన్ అయిన అగ్రిగేట్స్ మీరు కలెక్ట్ చేసుకొని ఏంటంటే నెక్స్ట్ మార్షల్ స్టెబిలిటీ స్పెసిమెన్ ప్రిపేర్ చేయాలి. అండ్ కమింగ్ టు ద బిటుమిన్ కంటెంట్ బై వెయిట్ ఆఫ్ టోటల్ మిక్స్, సో మినిమం 5.2% తీసుకోవాలి. సో 1200 into 5.2 divided by 100. If you do, we'll be getting that is the quantity of bitumen should be taken. And bitumen grade, for grade 1 use only VG20, VG30. VG20 means that is 60/70 grade. Okay, so after this what you need to do, you have to prepare the specimen. So here you can see clearly, in the first attempt approximately 1200 grams of blended aggregate is taken, heated to a temperature of 175 to 190 degrees centigrade. The compaction mold assembly and a rammer are kept preheated to a temperature of 95 to 150 degrees centigrade. So you need to heat the aggregates to 175 to 190 degrees centigrade. So mixing the aggregates and heating there only. So later on 5 different binder content should be taken with the increment of 0.5. What I have mentioned, 5.2% initial.